In this video, I'm going to show you how to figure out the centripetal acceleration on the Screaming Eagle. And what you got to understand is that sometimes when you go through the bottom, as you sweep through this bottom, right, you get a super spike of g-force. Sometimes you don't get so much. And let me explain why. Okay, so let's imagine that this thing is sweeping to the right and that we're looking down from up here, right? We're going to look down this way, right? This thing rotates, right? And I think it rotates anti-clockwise if we look down from above, right? Let's imagine that it does. Okay, let's imagine also that the whole thing is moving this way. I'll call this the velocity of the pendulum. And then this velocity here is the velocity of rotation. Now, if you're on this side here, you're actually moving in the same direction. So velocity of rotation adds to the velocity of the pendulum, and you get super g-force. If you're here, though, as you go through the middle, then the velocity of rotation subtracts because you're going the opposite way. And you don't get as much g-force. You still get some g-force going through the bottom, but not as much. So I'm going to look at the case where we have these guys line up and we get the maximum g-force. So I'm going to figure out the maximum acceleration. You could nuance this. I mean, you could figure out like one of those or something like that. But that's is what I'm going to do. Okay. Now, to do this, you have to have done the previous video where you figured out what this pendulum velocity is. I just did it in the previous video and I got 13.53 meters per second, but you need to do it yourself, okay? Take your own video, analyze it yourself, okay? But I'm going to do this for this case, okay? So let's do this, right? So my velocity of the pendulum from the previous video is 13.53 meters per second squared, right? And then I need to figure out the velocity of rotation. Okay, so let me show you where we can find that, right? So go to the physics website, right? Go to Oaks Park, go to Screaming Eagle, right? And there's all the information. So we know that the radius of this guy right here, this little rotating part, is 3.4 meters, which means it's 6.8 across. That seems right. Okay, and we know that it's got a period of 4 seconds. So let's use that. Okay, so the velocity of rotation is going to be just the circumference, so 2 pi r over the period, right? So that's going to be 2 times pi times 3.4 divided by 4.0. So let's do that. 2 times pi times 3.4 divided by 4 is 5.34. Make sure you show that calculation. Don't just say, well, the velocity of rotation is 5.34. You need to show all your calculations. All right, so there we go. So we got that. We figured that out. And now, in this case, we can figure out the total velocity is going to be, if they line up, if they're in the same direction, is going to be the sum of those. So 13.53 plus 5.34. 13.53 plus 5.34 is 18.87. So that's how fast you're going. That is, by the way, times 2.237. That's 42 miles an hour, and I believe it. You could be going that fast. You go pretty darn fast through there, right? So that's how fast we're going. So now to figure out our acceleration is going to be v squared divided by r. So, but what to use for r, right? R is going to be this distance here, right? That's our r. That's what we are going to use. Okay, so what is that? Well, just go back to the website. That is about 10.5 meters right there. Okay, so let's use that. So we're going to go 18.87 squared over 10.5. And remember, this is like our maximum. So I'm going to square that guy divided by 10.5. And I get 33.9 meters per second squared. Now that's the g-force of just the ride, and that's like 3 g's, right? Okay, but as you go through the bottom there, of course, you always feel 1 g plus the ride. And as you go through the bottom here, of course, you're accelerating up, so it's going to be 1 g. It's going to be 9.8 plus 9.81 plus 33.9, right? So you can add 9.81 to that, get 43.7. So then the question is, do you see that on your meters per second squared? Do you see that on your Sensor Kinetics Pro data, right? Now I'm suspicious about this value here, so you better check that. I've done this calculation and gotten as much as like 50 meters per second squared, but you'll have to see. You'll have to look at your data, you know, and this might be a better agreement. I just don't know. Anyway, That's the dealio.